Alright, hi guys. So day one of your homework, we're going to do exploration one. And we're going to end up using some of this knowledge in day three. You will have a notebook check on Friday, and I'll check last week's homework along with this week's homework, and you will have a quiz on Friday. Alright, so this tells you to work with a partner and use a dynamic geometry software to draw any scalene triangle and label the triangle A, B, and C. So we're going to do that, and then we're going to draw a line and call it DE and reflect that line ABC and DE to form triangle A prime, B prime, C prime. Alright, so we're going to go grab our dynamic software, and we're going to use GeoGebra. You know, that was my favorite. So let's go ahead and draw our picture. So it told us to draw a triangle A, B, and C and draw it scalene. And scalene means none of the sides are the same length, so that looks about scalene. Okay, and then it tells you to draw a line. Alright, and call this line EF. Ooh, okay, there's our line. And then, is that line supposed to be parallel? And it says draw any line. Okay, so I'm drawing a line, and then we're going to reflect this line. So we're going to take this triangle and we're going to reflect it, oops, across it's not going to act right. Give me, it's only pick up the wrong parts. Hold on, let me do it again. I might need to move this down. Give me a second, let me move this down so to act right. Alright, so there we go with my scalene triangle. And we're going to reflect this across this line. Alright, there we go. And let me go and rename this right quick. Oh, it's labeled like that. Alright, so they just have the ones on there so you'll see the first reflection. But you see the primes up there. So we reflected it across that line. And then it told us to draw a parallel line, draw a line parallel to line DE, and then we're going to reflect the A prime, B prime, C prime again. Okay? So I'm going to take another line and I'm going to draw it parallel. Alright, so this line, there we go. Now I got a parallel line to line DF, and then it tells me to go and reflect this one over this line, and it got some strange letters in there. Let me go and try to get rid of some of them. Alright, let me move these letters that are not supposed to be there, that's cramping our style. Okay, so there's our C prime, there's our B prime. And then we go move this letter out the way. I'm going to put this, I won't go too far. But alright, there's my double prime. Okay, so we did what it told us to do, and you can ignore those extra letters. And now it says draw a line through point A that is perpendicular to line DE. Okay, draw a line through point A that is perpendicular to line DE. Alright, so I'm going to click on this point. Tell it to draw a perpendicular line to this one. And it needs to go through point A, and then automatically put another point on there. Let me see if it'll move it. Alright, so there you go. And it's telling you, what do you notice? Well, I'm going to tell you what you can pick up here. The piece right here, first of all, there's a couple things I noticed, but let's go ahead and look at this. The piece right here is broken up into, I'm going to put it in two different colors, a piece right here and a piece right here. Okay, so if I add these two pieces together, I get this piece right here. So what I'm going to say I noticed is is if I do if I cover, well, I noticed that it seems like the distance here, the yellow and the pink would have the same distance. That's what we're going to write. It seems that the piece in the middle and you know what? I want to go measure that. And let's see if we can get some measurements on there to test that theory out. Okay, let's see how good this technology is. Will it give me the length of a segment? Let's see if I placed a segment from here to here. And let's see if it'll give me the length. It's not going to measure that for me. But, okay, so this is just to line up. Alright, so that's what it seems like is going on here. That's what it seems like. And we'll get some more stuff in there. Okay, also what we can notice is, let me see if the other question asked you this. It's telling you find the distance between points A and A double prime, and then find A and A double prime, and find the distance between the two parallel lines. What do you notice? If I take I don't think I have a measuring tool on here. If I had an actual measuring tool, and let me see if I can pull out a ruler here, and I can show you. Let's go to Files. Let's go to Tools. Let's go to Math Tools. And let's get a ruler. Alright, so if I measure this in, let me flip this over. Oopsie. Let's measure this in inches. And let me break this down. So, alright, so if I measure this in inches, if I go from here, it says from A to A prime, so this would be 5 inches. Did it say A to A prime or A to, it says A to double A prime. Alright, so if I measure from A to double A prime, I get about, about 8 inches? Not 8, about 6 inches? Let me see. Yeah, that look about 6 inches. No more than 6, about 7, just about. Or maybe about 6.8, somewhere around that corner. Okay, and then it tells me to measure the middle. So if I slide my little ruler down and I measure from the parallel lines, it looks like, oh, we got something here. It looks at about 3.5. Okay, so from the middle is 3.5. So let me write this down. Okay, so between the two lines, it looks to be about 3.5. And if I go back and measure the whole thing, it looks to be almost 7 inches. Okay, so we get 3.5 inches. And then from A, so we're just going to say line segment A double prime is 7 inches. So what do you notice here? That the distance between the two parallel lines is 2 times the distance of the points from A to A prime. That's what you notice here. So between the two lines is always going to be half the total distance of the A to the A prime. So from the beginning of the point to the end of the point. So let me show you that picture again. So the beginning of the reflection to the end of the reflection is double the length of what's in the middle of the two the middle of the two parallel lines. Okay? So it says hide triangle A prime, B prime, C prime. Is there a single transformation that maps ABC to A prime, A double prime, B double prime, C double prime, and explain? Well, if we got rid of the one in the middle, let's just ignore it. And if I take this and I put it on top of this one, so if I take the pre-image and put it on top of the second image, then we notice that it is exactly the same. So we would say it was translated. So you can say, so right here you can say 2 reflections. Oh, well, let's say this. It was translated, and you say because you are able to slide the segment on top of the other. Alright, now it says make some conjectures here, and then it says to test it. You could test it on your own, but I'm going to tell you what the conjectures are, and this is what you need to make sure you get, is that 2 reflections across parallel, and that's a symbol for parallel, lines creates a translation. So if you do 2 reflection across parallel lines, you're going to create a not a reflection, but a translation. Just like if you create a translation, and just like if you actually reflect across 2 perpendicular lines like we did in class last week, then you create a rotation. For an example, if I reflect this point and then across the y-axis, and then I reflected across the x-axis, then that created a rotation. So I reflected across perpendicular lines. Whereas what we just did here is we reflected across 2 parallel lines and we created a translation. And then that's one conjecture that we're able to find. And we can say the distance. The second conjecture is the distance. So this is number 2. This is the first one. Between the two parallel lines is half the distance between A and A double prime. So those are the two conjectures you need to understand, especially that conjecture 1. And then you can go and play with the dynamic software yourself and figure more out. Okay guys, see you in class on tomorrow. Bye.